Hello, welcome. Let's try to solve another Leetcode problem. 287. Find the duplicate number. We are given an array of integers nums, and inside it's gonna be n plus 1 integers where each integer is in the range. It is a positive integer and it is in the range from 1 to n inclusive. So this is a very important information. Because if we are giving such n plus 1 numbers and each of the number will be from 1 to n, it means that there must be a duplicate. And we need to find the duplicate. There's only one repeated number in nums. So for example, this is 2, the repeated number, and this is 3, and this is also 3. We must solve the problem without modifying the array nums. So this means we cannot use actual memory. So we cannot use actual memory because it must be constant actual space. And let's check the constraints. So n should be 10 to the power of 5, and nums length equals to n plus 1, and nums I from 1 to n. And all the integers in nums appears only once except for the repeated integers. It can be 2 or more times. This is very clear. The problem can be solved by array hash. So the idea is also very similar to other array hash problems. So for example, we have an array like we have 1, 3, 4, 2, 2, and how can we find the duplicate of 2? Yes, we can find it easily. So for example, if it is 1, so we're gonna have a recorder. So we will have a mark of it as -1. Why? Because if it is 1, we're gonna use the first index. So 1 minus 1, it is 0. At the first index 0, we're gonna mark it as a -1. So if this is 3, we're gonna check the second index because index 2, because it is 3 minus 1. At the index 2, we're gonna give a minus. So this is gonna be index 2, and this is the index 1. This is 3 and 4. So what about the next index? So for the index 2, because we've already changed it to a negative number, but it cannot be negative for the index calculation. It has to be positive. So we're gonna use an absolute value of this 4. So it's gonna be from -4 to +4, and then we're gonna check the index. So 4 minus 1, it is 3. It is here. We're gonna mark it as a -2. Now let's check this one. Now let's check this. Because we've already checked the second index. Now let's check the third index. It is here. First of all, we're gonna turn it into a positive number. -2 becomes +2, and then we're gonna use 2 minus 1 as at this position. It is index 1, and we're gonna mark it as a -1. Up to now, there's no duplicate. Now let's check what happens for the final number, this 2. So for this number 2, first of all, we're gonna check the absolute value. It's gonna still be 2, and then 2 minus 1, it is 1. So we're gonna find the index 1. So what happens? Because at index 1, it has already become a negative number. It means at this position, it has already been marked. It means there must be a duplicate. Because if we didn't mark it, it must be a 3. Now it becomes a -3. It means this number has already been marked. So we're gonna return our duplicate number. So it is this number 2. So the process is not so difficult, but we need to have the idea of the array hash. Basically, we're gonna use the array index as our case of the hash table. Now let's prepare some variables. N gonna be the length of the I'm not sure if I need to use this n or not. But let's just start the enumeration maybe. So for I enumerate the nums. First of all, we have to turn this n into an absolute value of n, because we're gonna use it for calculating the index. So the nums n minus 1 would be minus absolute of nums n minus 1. Of course, we may meet a lot of bugs, but we need to fix that. Yeah, especially for here, it must be use absolute, and here must be absolute. Yeah, but when we can turn it into a negative value, we have to check. So, yeah, we have to check it. So if this nums I equals to 8, it means we've already find. Yeah, if it is equal to a negative value, so it means we've already find it. And what are we gonna do? So we're gonna just return current number, this n. Otherwise, so we're gonna set it. Yeah, so we're gonna set it to be a negative value. So this will be the entire code. As you can see, it is not so long, but we need to think about it. What is the whole process, and how can we solve it like this? Yeah, as you can see, it works. Now let me submit it to prove it can pass all the testing cases, and the time complexity is O(n), and the space complexity is O1. As you can see, it's pretty fast. Yeah. So maybe if you forget about this one, n to absolute of n, you're gonna make a mistake. Yeah. And it is also obvious. So let me print out the nums. You're gonna see what's gonna happen. Yeah. So if I print it out, you're gonna, yeah. So this is just because, as you can see, we return a negative value. That is not impossible. Yeah, because this n must be a positive value. Sometimes if you turn it to a negative value and then use it, you're gonna make mistakes. So this is why we have to turn our current number to be a positive value. Maybe you think it must be positive because we did the operations from here. I mean the if part, else part from here. We can assign a value to be negative. Basically, this n should be always be positive, but sometimes we're gonna set it to be a negative. So while we are checking this number, we have to turn it into a positive, and then start our check. Yeah, if we find a number to be a negative number of itself, so this basically means we've already found a duplicate. Yeah. I think that's for today's question, and there are a lot of similar problems like this. Use the array hash. You basically need to understand why we can use array hash, because all the numbers is from 1 to n. 1 to n is similar from 0 to n minus 1, and the index is 0 to n minus 1. That is why we can use it. Thank you for watching. See you next time.